Today we'll be teaching you how to solve quadratic equations by factoring. This is the flowchart to show you how to solve quadratic equations by factoring. The first thing that you have to do is see if your equation has a greatest common factor. If it's a binomial, you'll solve for a difference of squares. This can be shown by a squared minus b squared equals a plus b times the quantity of a minus b. For trinomials, you'll do trial and error. We'll get into that later. GCF is the first thing you have to look for when you have a quadratic equation. For 16x squared minus 64, you can pull out 16. That'll be your GCF. For non-example, you have 3x squared plus 5. There's no GCF in this, so you can't factor it anymore. 4x squared plus 2x minus 30 is our example. A GCF would be 2 because all three of these numbers have 2 in them. If you pull out 2, you'll have 2x squared plus x minus 15. Okay, so now you have to list the factors for your a and c value. 2 is prime, so the only factors that multiply to get you 2 would be 2 and 1. 15 has multiple factors, so you can do 1 and 15 and 3 and 5. Add in 2x and x because it's prime, and then add in 5 and 3 because they can multiply. They can add up to give you 1 if you multiply all these. Set both sets of parentheses to 0 and then solve for x. For 2x minus 5, you'll just add 5. For x plus 3, you'll just subtract 3. Your answer would be 5 halves and negative 3. If you have a trinomial, you'll be doing trial and error. The first step is to write factors for the a and c values. Then put in one pair of factors for both terms and 2 sets of parentheses. The third thing you have to do is multiply the last number of the first set with the inner number of the second set. Then you multiply first number of the first set with the last number of the last set. If the two products add or subtract to give you the coefficient of the b term, you have your answer. If they don't, you'll just have to do steps in 3 and 4 again and see if they'll add or subtract to give you your b term. These are our 2 examples for trial and error. With the first example, a is 1, so the only things that can multiply to give you 1 is 1 and 1. 4 has 2 sets of factors, 1 and 4 and 2 and 2. So you have to see which 2 of these will add or subtract to give you negative 5. For this, it would be negative 4 and negative 1. Negative 4 minus 1 gives you negative 5. Set both of these sets of parentheses to 0 and then solve for x. Your answer will be 4, 1. Our second example is 2. So this will be a little bit more complicated. 2 is also a prime number like 1, so you'll have 2 and 1 as your factors. 1 is also prime, so you have 1 and 1. Put 2 and 1 in your 2 sets of parentheses, and then put 1 and 1 in your 2 sets of parentheses. These can both add up to 3, so you know that your answer is right. Set both sets of parentheses to 0 and solve for x. If you did this correctly, you'll have negative 1 half and negative 1 as your answer. Difference of squares is for binomials. Difference means subtraction, and squares means perfect squares. So for your examples of these, you'll have subtraction in it, and then perfect squares. 16 is a perfect square. 4 and 4 can multiply up to give you 16. And 64 is a perfect square because you can multiply 8 by itself to give you 64. A non-example is 5x squared plus 60x because these aren't perfect squares and it doesn't have subtraction in it. Our example for difference of squares is 25x squared minus 64. For this, you can multiply 5x by itself to give you 25x squared. So add 5x in the 2 sets of parentheses. 64 is a perfect square, so just add 8 and pop negative 8 in your 2 sets of parentheses. Put both sets of parentheses equal to 0 and solve for x. If you did this correctly, you'll have 8/5 and -8/5. Our tips for this is to always check your work. If you don't check your work, then you might be wrong. So you have to do that. When the directions say the factor to solve, you have to do this. You have to put x equals one or two numbers, or if there isn't a solution, you just put no solution.